The end of vibe coding. The rise of the Neuro-Symbolic generators. Beautiful code is often a representation of a vision, a three-dimensional concept that we can see and navigate with our minds. Programmers rewriting network card drivers for high-speed trading or programming 3D game engines can't do this. They are forced to optimize. But we must, as not to get lost in the mountains of code before us, especially now that they are generated by artificial intelligence. I won't talk about program architecture much. It is an application tree, on top of which layers of application trees can be mounted and layered one on top of the other, so that any one application can be isolated and properly examined. There are commands. They are the words of the language that we communicate with computers, and services that provide more commands, but now in a specific context. Commands that are attached to something. And services can depend on other services, creating yet another tree. Trees are a repeating pattern in programming. Database depends on storage. Data storage depends on file system. File system depends on OS or virtual machine. Write command is different in different contexts. app.write, db database.write, fs.write for file system, os.write for wherever this whole thing is running. It could run in a web page, in a virtual machine, an isolated container. Who knows what the OS even is these days? And an input box in your user interface needs to be bound to a signal, an intermediate thing between database and data input. When database updates, it updates the signal which updates the input box. When an input box changes, it updates the signal, and the signal notifies the database. Hey, quick side note here. A signal doesn't react if it receives the same data. So you can update the database based on data from an input box, and then the database can say, hey, oh my gosh, I just updated, let me update the signal. But the signal will not respond because it's the same data. So a signal really is an in-between that evens out a bunch of things. All of these patterns and ideas create intense simplicity. Repeating self-similar leaves on a tree, uniformity and clarity, and, of course, the ultimate aim, code readability. AI instead makes things work without all of these extras that even out the wrinkles. It doesn't need them. It is not a human mind. It is a precise thinking machine. But when a human looks at that code, well, it's difficult to read. Machine programming hurts readability. It doesn't always assure clarity, and it erases forward vision and upgradability, because AI can just rewrite the next version from scratch in just about 12 minutes. In short, today, the human is removed, and the AI does high-precision work. Humans are no longer welcome in the code then. They are messy. They create unnecessary and eventually leaky abstractions. The inefficient self-repeating trees and commands are not welcome in the machine world. It doesn't need to remember how everything's connected. It already knows how everything's connected. This is good in most ways. but it also creates a persistent reliance on thinking machines to do all the changes, on their precise way of multi-solving all the problems before them. Here you are no longer able to just hop into the code and make some obvious changes. There may be islands of multiple peaks that AI would know to visit and you just can't understand, because human minds are smaller than AI minds. So, we have a fork in the road: precision code or human-readable code that does not rely on constant need for AI. The smallest possible solution to this is to stop AI from writing code directly and teach it to edit a code generator file, an XML tree similar to HTML. The tree will complain when it is used wrong or assembled incorrectly. The tree has rules and tests built in. Here, AI can add a new program component with commands, and the tree can even ask the AI if the commands would be placed better somewhere else. This is the symbolic part, communicating, managing the neural part, which is great but less precise. The AI does not get to decide how the final code is written. It must operate based on rules of the code generator tree. Previously, some years back, it was outrageous to talk like this, because to build a code generator, you need to enter all the code it will generate. But now, not as code, but text templates. Yuck! Which is not even close to code. It's not language. It's not readable text. Not anything standard that you have tools for, but a mess of unreadable soup of mishandled concepts, and then variables that look weird. Previously, code generators were messy, required large efforts, and they still did not generate the vision that the person held. But today, with AI having the ability to do all the programming, including replacing code templates with the more precise code mods, not always another mess, mind you, as valid program statements can serve as template spots, and templates which themselves can be isolated and independently tested by tests written again by AI, so the code can be of high quality. In short, the creation of a harness that generates beautiful human-friendly code, and only with the use of local AI, and oftentimes just once, is now possible. More than realistic. Probably just a single afternoon session with AI. If you create a tightly controlled AI harness, and the resulting code will not only clearly not require AI to edit, but also show the programmers that the code is easy to understand, easy to edit and manage, you will rise to the top, above today's coding AIs. This is still neuro-symbolic programming, neuro being the large language models, the chaotic minds of today, and symbols residing in your code generator instructions. It's a tree, it's a world, you can think of it that way. But here, the symbolic part leads the way, unlike in standard coding agents. And large language models create the top trees and bottom templates only. The heart of the matter is just a code generator that converts the tree to code by use of code templates. And, well, theoretically you could add a visual programming layer on top and remove the need for a programming AI altogether. You just sit there connecting lines together, and the program generates all the code beautifully and perfectly. This text right here is enough to get you and your AI started on this project. The result is a coding agent that specializes in a single language and does one thing well. You end up with application seeds rather than applications. Retention of control and beautiful code rather than what AI thinks is right. And yes, library upon a library of code templates for one language, for another language, for a whole new language. Not to mention that the entire blocks of code that are demanded by the browser or some application framework, all those boilerplates, can now be turned into a single word command or node with minimal attributes, especially if you structure everything as a tree again. This is one small example of countless research areas where you can rise straight to the top to make breakthroughs that leave even the well-educated scientists in the dust of the past. Please, use symbolic programming as a harness for the precise but chaotic broad blast radius AI of today. The two, symbolic and neural, combine to create something new, something cleaner and stronger and more precise. The future has arrived, but it now awaits your symbols, your scaffolds, and your code adventure games.